This conference
This
will now be
conference will
recorded.
now be recorded. Okay, so in today's discussion, let us understand about the set implementation. We have already seen about the hash set. Okay, we understand about the hash set, and then there is one more implementation of set is what a tree set. Tree set. Okay, so the purpose of tree set is sorting. The main motto or objective of the tree set is sorting, whereas like you don't see any sorting mechanism for hash set. And of course, you cannot expect the same order what you insert. That's what insertion order is also not preserved in case of hash set. So, but if I wanted to get the elements in a particular order, so for sorting purpose, so we have something called tree set. This is implementation of an interface called sorted set. So this is another interface we have in collections. Okay, so set is also what interface. Set is one interface and sorted set is another interface. Right, sorted set is another interface. This is, sorted set is extended by set interface. Okay, this is extended by sorted set is extended by set interface. Set, it is extended by sorted set. Okay, set is extended by sorted set. So both are interfaces. So if you look at the hash set, it's a direct implementation of set interface. But if you look at tree set, this is implementation of what tree hash set, sorted set. Tree set is the implementation of sorted set. So it supports the sorting. It supports the sorting. Okay, if you look at this, so set s is equal tree set. I'm going to create an object for tree set. Okay, so tree set. Okay, tree set. So generics, if you want, you can keep the generics for now. Just I'm going by string, either strings or integers. Anything is fine. So let me go with the string, meaning that what this is tree set allows only strings to add. If you try to add any other type other than string, you will get compiled error. You will get compiled error. So java.util set, java.util tree set. Okay. Now I want you to see, look at, I wanted to look into the tree set implementation. Okay, so this is what tree set constructor. Internally, it is using tree map to create to construct this tree set. But anyhow, if you look at the tree set, this is implementing what navigable set. This navigable set is introduced in JDK 1.6. Okay, prior to that, tree set is directly the implemented class for the sorted set. But JDK 1.6 and what there is in between called navigable set, in between tree set implementation to the sorted set. So navigable set is extended by what sorted set, meaning that so here set sorted set, and we have something called navigable set. This is introduced in JDK 1.6 version. It's not there from JDK 1.2. Okay, so navigable set. So this is an implementation. Tree set is an implementation for what navigable set. Okay, so that's what you can see here. The order. So sorted set is extended by what set. Okay, set sorted set, then the navigable set. Okay, and then tree set. Tree set is what? This is a class. Tree set is a class, right? Tree set is a class. Now go back to that navigable. Where is our example here? So I'm creating a new tree set object. I'm creating a new tree set object. What it does, it is going to sort the elements. Okay, let me add few elements to this set. Add of. Okay, so I'm adding some elements to this. Okay, xyz. Okay, s dot add of. Okay, so probably hello. Let me add s dot add of maybe Java. S dot add of Python. S dot add of. Okay, something like I'm I'm just adding a few things, HTML. Okay, so if you print this now, if you access this, as, what is the output that you can expect? What is the output that you can expect? Should be sorted. Okay, so now you can see this. Okay, HTML, hello, Java, Python, and XYZ. So is it following any particular order, or H comes before J? Is that HIJ? Correct. And Python, then XYZ. So if we have two words which are starting with H, okay, which are starting with H, then it goes by the next letter to sort it. So this is a capital T and this is a small e. So basically this is going to come first. So if I keep small t, okay, HTML something like this, now we can see the order. So hello is coming first, now HTML is coming next. So if there are two strings which starts from H, so then which should come first, that is depends on the it goes by next letter. Next letter is also same, then it goes by the next letter comparison. So in that way it sorts the elements and provides the output. Okay, the sorting mechanism, so as it is a string, right, it goes by string comparison. So just we go to string class, so there should be a method, okay, compare to method. So here is that internally that is going to use this particular method to compare it, whether both the strings are equal or not, or which comes first, which comes later. So this is going to compare the strings lexicographically based on the ASCII code values. Based on the ASCII code values, it's going to compare, and okay, it's going to, this is a case insensitive order if you want. Anyhow, these are the implementations of the string class, because you have given, you have added string elements here. So when you add first element XYZ, it will add it, and when you try to add the next element, then it is going to compare this one and this one with the second string using string compare to method, internally string compare to method, and based on that, okay, based on that it is swap if requires. If this should come first and this should come later, then these two strings are going to swap. Okay, then when you are trying to add the next element, again it is going to compare with each letter of each element of the existing collection. Again it will go for sorting. So like that all the elements will be sorted. By default it's going to sort in ascending order. It's going to sort ascending order by default. Okay, however, if you want to customize, you can customize this behavior. Okay, you can customize the sorting behavior always. We have customized sorting. Okay, this is the default sorting. So that's starting from A to Z. If you want to get the in a reverse order, Z to A, then you can write your own customized sorting technique, and you can follow that. We can implement that. Okay, we'll see that. We'll see the customized sorting also. We have a concept of default sorting as well as customized sorting. Okay, default sorting and customized sorting. I'll tell you that. Okay, so this is an interview question again. Okay, this is an interview question. Sorting, we have two sortings. Okay, one is a default sorting. One is default sorting. Default sorting is already implemented inbuilt sorting, and okay, so it will go by that. Now if you have if you wanted to customize your sorting, your list, then you can go by this customized sorting. Okay, so default sorting is, we achieve this default sorting using an interface called, comparable. We have something called comparable, and this comparable is available inside this particular package, java.lang package. Java.lang package is comparable. So if you implement this, your customer object, if you implement this comparable, yes, so that go with the default sorting order and customized sorting. So we can achieve this using one more interface called um, comparator, that is available in java.util package. Comparator that is available in java.util comparator, that is available in util package comparator. This is to customize the sorting. Okay, let us understand that. So if you go back to this example, this is string case, right? If you look at the string class, this must be implementing comparable interface. String class, this is very important. This is very important. Okay, so string class is implementing what? Comparable. String class is implementing what? Comparable interface. So if this is if our class is implementing comparable interface, then it means that you can compare two strings object. It gets that ability of comparison. Gets that ability of comparison. Okay, so you can go by string, you can go by integer, float, all these things, right? All these things are by default implementing um, a comparable interface like integer. If you take integer, so for example, just look at the integer class. So integer class implements what? Comparable interface. Integer class implements what? Comparable interface. You take any other thing, so double. Okay, so this is different. Double, this is primitive. Okay, this is primitive, and this is the wrapper class which is built on top of the primitive double D. Okay, so for every primitive class we have a corresponding wrapper class. This is a double object. So if you see, double is implementing what? Comparable interface. Okay, so now the question is, so if you wanted to sort, if you wanted to go by default default comparison with the default comparator, okay, so your customized object must be implementing that what? Comparable interface. So here, as we are adding string elements, so we don't have to worry about that. So for example, I have a class. Okay, I have a class employee. Okay, I have a class employee, and in that employee class I have id, I have employee name, I have salary, something like that. I have things. Okay, I have things like this, class employee. Okay, now if I wanted to organize this collection of employees and I wanted to sort them employees by default, okay, then how do I do? So here I'm going to add these employee objects. I'm going to add these employee objects to my set. So set of what type here? Employee type. Okay, employees set. New tree set of, okay, few set of employees. Okay, so this is what? Employee. Okay, employee. So to this employee set, what objects I should add? I'm going to add new employee. So this is what? Adding employee objects to my set. So basically collections are what? Is a group of things, group of objects. What kind of objects? Can be anything. So that can be integer objects, group of integer objects, group of string objects, group of boolean objects, group of anything. So group of employees also, group of students also, group of products also, group of insurance policies also, group of doctors, group of patients. So any class object you can add to the collection, right? So here I'm trying to add my employees to the collection. Okay, so the scenario is like I'm adding the employees to the collection. So here, so whenever I'm creating a new employee, I wanted to initialize the details of employee. Okay, so let me okay, so let me add the constructor. Yes, I wanted to generate the constructor to this. okay, with the fields. So I have ID, ename, salary. This is what. So now I can provide my employee ID, I can provide my employee name, and maybe salary. Okay, so something like, so I can take it. This is what one employee. Like that, I can add multiple employees to this set. Okay, now so 2, 3, 4, 5, 6. So okay, okay, something like some random numbers I have added. Okay, okay, some random data I have added. So how many employees I have? Total 6 employees I have added. 6 employees I have added. Now if I print this, how it is going to print? Employee set. Okay, just try to understand, working with the collections of primitive type. Like primitive types are string type, whatever it is, integer or string. So those are existing classes. Those are existing classes already in Java. So working with them, they have already certain predefined code. Based on that, it will work. Now here is the scenario where I have my own class. I have created my class. Okay, here I have created my class. Okay, I have created my class, and I'm adding the class objects. This is one object. Okay, hope you have no confusion. If you have confusion, just what you can do is you can prepare this employee object like this, and okay, you can add this employee to this. So instead of adding like this, I just directly creating object and adding to this. Is that clear? So because why? Because I'm not going to use this anywhere else. So there is no point of maintaining another variable here, local variable. Okay, so you can directly add this, so you can avoid this unnecessary extra variable here. So that is why I have used directly this new employee. All right, now can you see there is one compilation error? So here itself we can understand the reset. So the type employee is already defined. Okay, I think we have employee class already in our um, default package. So here if you see, we must be having somewhere in here employee class, employee manager. I think we should be having employee class here already. Okay, so we have employee class already. ID, date of joining, with all this we have equals method. Okay, so hash code method, we have written Pojo class some time back. Okay, so okay, for now I'll just rename this employee to employee model or so. Okay, just I'm okay. All right, so now still it is giving error, right? What is that error? See that. So okay, because we need to change the constructor also, right? Okay, change this also. Still anything else now? Okay, so now no error. So here if you see, employee model object, I have added 6 model objects. Okay, employee model object, 6 model objects. Now I'm printing this employee set over here. Okay, so what I'm doing here is very simple. Okay, so I have created my own collection objects here. This is what my collection object, and in that collection object I have added multiple objects, customized objects. These are customized objects, not a primitive like integer or float or boolean. No, So these are customized objects. I have added, okay, 6 customized objects of what type? Employee object. So this is employee object, one employee object. This is another employee object. Okay, so I have added a group of employee objects to this collection. Instead of primitives, I have used customized objects over here. I have used customized objects over here, right? So what is this? E1, E2, E3, 6. So these are, okay, so these are A6 are employee model objects. So I have created, my collection takes any kind of objects, right? This is what tree set. To the tree set, I have added employee objects. I have added employee objects. So every employee structure is something like this. Employee model has the structure of what? The parameters. It has ID, name, and salary. So these are the properties it has, employee model properties. Okay. Now, so just observe here in the previous scenario. So here I have added all string objects, right? Here I have added all string objects, and it is comparing the string objects. Okay, it is comparing by default. It is comparing and giving the result in the ascending order, right? Now, so by default, on what basis my tree set is going to sort my employees? That is the question. Understand the problem here? By default, on what basis? By default, on what basis my employees are going to sort? Any guesses? Is it going to sort by name, or is it going to sort by salary, or is it going to sort by ID? On what basis it is going to give? On what basis it is going to give the output? That is the question. In case of string, it follows the ascending order. String comparison, it follows that, and it provided the output. Okay, no issues. The similar way, if you can take integer also. Okay. So it is going to provide the data in ascending order. Okay, you have 100. Okay, so you have 20. Then you have 15. So zigzag. So numbers are added in not a particular order. Okay, but while printing, if we print this result, okay, you are going to get, okay, in a particular order. You are going to get in a particular order. So this is, say, S1. Okay, this is the case with integers. Okay, this is the case with integers. And below I have, okay, so from here to here I have employees. Okay, from here to here I have employees. Correct. Just for commenting that, just observe integer and string, both of them. Strings we have already seen. Now integers, you just observe integers. So 50, 20, 44, 55, and 100. So it is following ascending order by default, right? So if you look at the integer class, so integer class is implementing comparable. Okay, comparable is the interface, and we know that if you are implementing one interface, so it is compulsory to implement the methods of that interface or not in the implemented class. So hopefully you remember that. So if you have an interface and your class is implementing that interface, it is compulsory to provide implementation for the abstract methods of the interface, right? So here compare to method is available, in comparable interface. So meaning that this compare to method must be implemented where? In the integer class. If you look at this integer class, so it should be implemented. This compare to method is implemented, and internally this is calling compare method. So here value and another value, both the values it is giving, and it is so you can check this implementation. If x is the first value, y is the second value. If first value is lesser than the second value, okay, first value is lesser than the second value, then returning -1. Otherwise, if both are equal, then returning 0. So the otherwise they are returning 1. So basically negative value, 0, and positive value, that is what they are returning to compare it. Okay, so this is just comparing to integer values. In the similar way, what about the string class? String class is also implementing comparable or not? String class is also implementing comparable, and here also this must implement what? Comparative. So here also the comparative method is implemented, and depends, it's iterating through each character by character from both the strings. C1 is from the first string, C2 is the character from the second string, and if both are not equal, then just returning the difference and incrementing it 1, and finally returning length -1, length minus length 2. This is one kind of implementation, okay, they are following. Okay, so this is just to compare two strings, but it is implemented compared to method is implemented. That is where it is going to get the ability of comparison. In the similar way, when you are working with your employees, okay, you are working with your employees, group of employees, along with the sorted set, you are giving this employee to um, sorted set implementation, which is what TreeSet here. So if I run this, on what basis it is going to execute? If you run this, you are going to get, okay, an exception, that, okay, class cached exception. This you have to remember. So while working, you definitely will face this, okay, class cached exception. During the exception, I have explained you when we get class cached exception already, but still again you can check this. Employee model cannot be cast to comparable. Employee model cannot be cast to comparable. So meaning that, so here you have an employee model object here, okay, and you added this to employee set, okay, and then again you are trying to add another employee model object. So what it tries to do is, if you are adding this employee object to TreeSet, that must be a type of comparable. That must be a type of comparable, meaning that must be a child of comparable. So then it acquires that ability, okay, so it can compare, it can get the ability of comparison. So otherwise you cannot compare it. On what basis it has to compare? It doesn't know. On what basis it is going to compare? It doesn't know. So it must be comparable. It must be comparable. So it must be comparable. So your employee model must implements what? Must implements what? Comparable. It must be implement what? Comparable. And on what basis you are going to compare two employees? Based on the ID, or based on the name, or based on the salary? What do you wanted to implement? So I wanted to go by employee name or employee ID. So it's up to you. So I wanted to go by employee name. So here, what is the type of employee name? String. So it should be string type. It's a generic type. We should specify here, right? So my employee model is implementing an interface, then it is compulsory to provide the implementation for that comparable interface methods or not. We have comparable method, interface method, compare to. So we should provide implementation for that. So your employee class should provide the implementation for this, okay. So should provide the implementation for this. So what is the method? Compare to method, add unimplemented method. So here it is what? Compare to method, okay. So here you are going to compare one string with what? Another string, okay, two string objects. So here compare, I'm going to compare, okay, I'm going to compare first employee object of employee name with the second employee object of employee name, right? So here the type should be the same. I did wrong, okay. It should be of the same type, okay. So it should be of the same type. So employee model, okay. So now what I can do is, as it is, I'm going based on the string. I'm going based on what? I'm going based on the strings. What is that string? Employee name. I wanted to sort my employee based on the employee name. So what I can do here is this dot, meaning this means and what object the compare to method is going to call that particular object. This means get. I don't have getter and setters here. Let me add the getter setters here. Okay, source generate getters and setters. Okay, so this is model object structure in general. Constructor with fields, setter and getters, hash code method and equals method also we have to implement. Anyhow, we'll discuss that also. Equals method and hash code methods. Okay, now come to comparative method. Get, I wanted to sort by name, get employee name. So this is a string, right? This is a string, and now I wanted to compare two string objects. And already I have in the string class I have already implemented comparative method, compare method in the string class. Okay, where is that string class? Come on, did I close it? Okay. All right, let me open this again. So here I have comparative method already implemented, right? So if you have string object, you can directly call this method or not. Why do you want to write all this logic again? So we don't have to write it. What I can do is I can simply call that method, get employee name dot comparative of another string. Another string is what? This object o dot get employee name. That's it. That's it. I will implement in this way. So what this does, okay, so whatever the object you are calling comparative method, that particular employee name is going to compare with the, this is another object, this is second object. Okay, so object to second object, you can just say object to dot employee name, you are going to compare with this dot get employee name. This is what first object. Okay, here this is what first object. So in the comparison, the first object. So based on this, it is going to compare. So now if you go back to this collection, when you added this employee object, okay, when you are trying to add the second object, so now this is going to call the comparison of like this particular employee object dot compare of this particular employee object, and internally it is going to execute the comparative method. As part of the comparative method, I am comparing the names. In this particular employee, first this dot employee dot get name is going to return me Venkat, and employee2 dot get name is going to give me what? This one. That's what object 2. It's going to give me what? This one. Okay, so let me keep either small or capital, so that you can get the things clearly. Okay, all small letters. Now run this and see the output. So you are getting some output, so there is no error, so no class cast exception. But if you observe the output, it is printing what? Employee model, that is what class name at the rate and followed by some reference, right? Some random address. So this is what the implementation of the super class object class toString method. It's going to call by default object class toString method. Okay, object class toString method is going to call. So just if you look into this object, so we have a method toString method. What is the implementation of this toString method is it gets the class name, at the rate symbol and hash. It's going to convert it generates the hash code of that particular class object, and it will convert into hexadecimal format. So it appends to this, and this is what the string it is going to return. That is what the output you can see: class name, employee model, at the rate symbol, and hexadecimal format of the hash code value of that employee model object. Okay, but I don't want that to print. I don't want to print that. So when I print my reference, I wanted to print, okay, I wanted to print the logic of my own. So what I should do, I should override the toString method, that's all. Okay, I should override the toString method. I don't want to print this particular super dot toString method. I wanted to provide my own implementation. So this dot, okay, employee id, get employee or employee name. I wanted to just print employee name, and I wanted to print, okay, salary. Okay, so something like I wanted to print, okay, employee name is this, okay, employee name is this, and his salary is this dot get employee get salary. So this I want to return this one, meaning that when you are printing a reference, so it is going to call the toString method, underlying toString method, and executes, okay, and whatever the logic you provide there, that is going to print over there. Now you can see this, okay, employee name is Aditya and his salary is 30,000. Employee name is Bala and his salary is 15,000. Employee name is Hari and his salary is this one. Employee name is so and so. Okay, all are coming in a particular, okay, in a single line. So I don't want that. I wanted to print object by object. Then what we can do? So we can go by for loop. Okay, we can go by for loop, and there is a concept of for each loop. I think I don't know if we discussed this already, but if not, just you have a look. It's very simple and straightforward. For each loop, this is the most of the loop that we use, most of the cases. For each loop, okay, for each loop, what this guy is going to do is, okay, what this guy is going to do is, okay, for each, this is what your collection, right? For each one, so for each one, in the sense, it picks up one by one. For each, it is going to pick for each of this collection. So till what, how many elements are exist, till it goes through the all the elements. For each and every element of this collection, it is going through. So you don't need a starting position, you don't need a counter, you don't need increment or decrement operators, anything. So for each employee object in the employee set, this is the collection bag. From this bag, pick up everything, each and every object, and what you wanted to do for each and everything, that you can write it over here. Okay, so if you wanted to print toString method, you can print it. Otherwise, you can just only print the name. You can just only print the name, employee name. Okay, just you can print the employee name. Now just to see the order, this is what, are they sorted or not? Okay, now you can see the names Aditya, Bala, Hari, Shankar, and Srini Venkat. So you can observe the order. These are ascending order or not? A, B, H, S, S, B. So these are in ascending order. So if you wanted to change this order, if you wanted to change this particular order, ascending order to descending order, what you can do is, you just reverse this one compared to, right, you are returning it. So you just okay, what you can do is, you can just flip this. You can just flip this. Okay, this is one way. Now you can see the order Venkat, Srini, Shankar, in reverse order it is printing. Okay, so that is what the sorting. That is what the sorting technique using a comparable interface. Okay, comparable interface. So what are the things that we have to ensure in case of working with the comparable, right? Default sorting. default sorting. Default sorting in Java. The first thing is, okay, default sorting with the customized object. Customized object in the sense that can be employee, student, anything. Okay. The first thing is, so our custom class, a customized class must be implements. Okay, what? Must implements what? Comparable interface. This is available in which package? Lang package, java.lang package. Comparable interface. This is the first thing. And the second thing is, as we are implementing this interface, we must provide implementation, must implement the method compare to, okay, compare to of that particular specific requirement. What do you want? Like you wanted to sort it by what property? Compare to method. So how to implement? So here just need to compare we need to implement the logic. We need to write the comparing logic on the specific property of class. Okay, specific property of the class. So in our example, I'm comparing using what? Employee name. That is the property. Okay, that is the property. Using employee name, I have implemented this comparing logic. Okay, so you can your class must be implement the comparable interface. Then it must implement the compare to method. How to implement that? So we need to write the logic to comparing a particular property of the class, using the particular property of the class, comparing the logic on the specific property of the class. So that could be any and what property you wanted to sort it, based on what property you wanted to sort, that property you have to give. Then so we can, okay, we can add the customized objects to the tree set. So now this is going to, okay, now this is the tree set. Okay, internally uses compare to method and it will sort. So is that make sense for you and understandable? So why we did not write in case of string and integer in the above scenario, we did not worried about all this, right? Because these are predefined classes which are available and where they have implemented all the compare to method. So the tree set is following that and comparing it. For integer also the same thing. Okay. So what is the point you have to remember is, when you are adding one object to the tree set, that object must be implementing what? That object of type what? Comparable. That object must be of type what? Comparable interface. So this is most important thing. Okay, important thing. Hope you got it, or else let me know. We can discuss again. Okay, this is what employee model, and what are the other things we did. So this is a straightforward properties, constructor, setter, getter methods, and then I have compare to method. This is what the main thing that you have to focus. Okay, so compare to method is going to take the same object, complete object, because in the object what property you wanted to sort. Tomorrow if you want to change, by salary, then you can simply say that get salary compare to of get salary. So we can just go by this. So now this is going to sort by the salary now, not by name. Okay, so why this guy is giving error is, okay, so this is a double, right? So it's a primitive type. So on the primitive type you cannot call this compare to method. What I can do is I can just typecast or else I can convert this to double object. So on top of it, you can call it otherwise. So you can directly you can write the code whatever you have here. So whatever you have here, you can just directly you can write the code here. Okay. So now go back. Okay. So just go back to this. So here instead of this, you can write your own logic if you want directly. These are primitives, right? Okay. What you can do? Uh, this dot get salary. Okay, if the first thing is greater than the second thing, OB is a 2 dot get salary. Okay, so if this happens, I just wanted to return a positive number. So that's what 1 as that. So you can return 1, you can return 100 or any positive value. Else if okay, this dot get salary less than obj2 dot get salary, then I wanted to return a negative value. So if it is not a negative or a not positive, then I'm going to return 0. That means that both are same. This one and this one, both the salaries are same. Then what doesn't matter, the order, it doesn't matter, you can keep it anything. So this is what your implementation. You have to write the implementation in this way. So this compares based on what? Salary. This compares based on salary. Now run this now. So you can see the things are arranged based on the order, based on the salary, based on the salary. Okay, if you look at Venkat, Hari, Bala, Shankar, Srini, and Aditya. So what I can do now is I will just print here along with the name or just else a salary. Okay. So now you can see the salary order. So it is arranged like 10,000, 11,000, 15,000, 20,000, 21,000, 30,000. So arranged in based on the salary or not? Sorted based on the salary. So that is what. If you want to sort it by employee ID, then you just instead of salary, just provide the ID. Okay. So based on the type, so you will be returning either 1 or -1 or 0. Based on that, it is going to arrange the in a particular order, either ascending order or descending order. Okay. The main thing is implementing comparable interface and provide the implementation for what comparative method. Okay, this is what numbers. So if already there is a comparative method implemented already on top of that particular guy, so in that case you directly use that. So instead of you write again implementation, so you can just use the existing logic. That is why so we have used this is fine. Okay, this is fine now. So because string is already implementing comparative, so that logic will execute and return it. As per that, it is going to sort it. Okay, if that is not available on our property, then we'll have to write the logic. So we understand the difference. Okay, so this is what salary based. Do you understand? Or is it confusing? The sorting? Do you understand? Okay, okay. So that's what the main thing here. So what is the problem with this default sorting is, okay, the limitation of default sorting is, okay, you can you will have to strict with particular uh, sorting on the particular property, right? So suppose your requirement is you wanted to sort the employees based on the name, okay, then what you do here, in the comparative method, you will compare based on the employee name, based on the employee name. Okay, tomorrow, so your requirement is changed, and they told that, okay, boss, I want to sort it by date of joining. So you have assume that you have a property date of joining, and they wanted to sort the employees based on the date of joining. Then what you have to do? Again, you will have to come back to your employee class. You will have to change this logic or not. You will have to change the logic, and you will have to rewrite this code to compare the dates instead of names. Correct? So that is what the limitation that we have in case of default sorting. In case of default sorting, so if you wanted to customize it, like, so you cannot do that. Again, you will have to change the source code, existing source code. Okay, and at a time only you can sort by only one property. Okay, we can sort the objects only on a particular property. We cannot have them sorted on multiple properties. We don't have that opportunity here. And also, if we want to change the sorting behavior using a new property, then we need to change the source code, existing compared to logic. Yes or no? These are the problems with this. But in our real-time requirements in general, they will be like, so they will be like, we should compare them in particular. 1 second, let me go to this. So can you see here? So I'm here in the C Java practice. Okay, so if you observe this header, I have a name, I have date modified, I have a type, I have size 4. So I am allowed to sort it by name or not. If I click on this, so this will arrange in based on the name. If I click on this date modified, these are going to arrange based on the date. If I click on type, these are going to arrange based on the type. If I click on size, these are going to arrange based on what size. So this kind of customization, if I want, then how I'm going to achieve using default sorting order? I cannot, right? I can do either by name or either by date or either by type or size. Only one. So while giving, so if I'm giving the default sorting of name, okay, default sorting of name, so that will be sort by name, and user wants to sort it by date, then again, okay boss, wait, so let me take that again for the requirement change, and will implement based on the date modified by changing the source code of that particular class, and based on the date comparison will implement it. Now it will work based on the date, but he'll be losing the comparison of using name, right? So he cannot achieve that. So this will be stick to only date. But how do I want, if I wanted to apply the sorting on all the properties, still I wanted to sort all of them. So that is where we need to go for customized sorting. We need to go for what? Customized sorting. So we need to go for customized sorting. The customized sorting we use using the using a predefined class called java.util.comparator. Java.util.comparator. So using this we can using this we can compare. Using this we can compare. We can provide any number of sorting and any number of properties. Okay. So this is not going to depend on this comparable comparator. Let it keep it default sorting based on the name or ID. On top of it, if you want to provide the sorting on the salary, if you want to provide a sorting on the date of joining or whatever, you can just create it. Okay, so that part we'll discuss tomorrow. Okay, so for today you just go through this example again and try to understand it. Okay, this is more important. Whatever we discuss in collection, each and everything is very very important, very very important. Okay, so you go through this and try to understand the default sorting. Okay, so we'll discuss the customized sorting tomorrow.